Hey there, my name is Alejandro, and welcome back for day 179 of me doing the Daily LeetCode challenge as I reach 1 year's worth of Greek contributions here on GitHub. So today's problem is for January 11, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 1400 exactly. Construct K Palindrome Strings. Okay, given a string s and an integer k, return true if you can, sorry, there's a little dust on my computer. If you can use all the characters in s to construct K Palindrome Strings, or false otherwise. Okay, for example, Annabelle, k is equal to true. You can construct two palindromes using all the characters in L and S. Some possible constructions are Anna, E. Oh, you can use them in whatever way you want? Wait, that's crazy. Oh no, but you must use all the characters in the string. Okay, so you can't just be like, just do A, and that's that easy, right? Okay, so you must use all the characters in the string. Okay, that's not that bad, right? Essentially, the point is like until you have 1 or 0 characters left at the end, essentially you can deduct 2 always, right? And if anything, I can do like kind of like a DP option, right? Is this only lowercase English letters? Yeah, so if anything, I can do a DP with 26 dimensions for like, number of A's, number of B's, number of C's, number of D's, a crazy, or, oh yeah, I can pass it a dictionary, but the dictionary will be all fixed sized every single time. So yeah, okay, we can just use that cheeky little convenient thing and so on. So the point is, well, if the sum of the values is less than or equal to 1, it's like, you just return 1. Okay, yeah. So yeah, immediately what I'm thinking of is dynamic programming. Finally, hopefully we're getting into a dynamic programming section. I'll be very nice and happy. If anything, here I'll do a dictionary, and I can be lazy. I can make a copy of the dictionary every single time because there's 26 lowercase English letters. So there we go, bada bing, bada boom. So yeah, so at the very beginning, what I will do is, so here we'll do self.s, self.k, just in case, are equal to s, comma, k. And here we'll say for letter in s, d is equal to dict of int, d of letter plus or equal to 1. And then we'll say return self.dp with dictionary, right? So here, what we will do is like, okay, ideally here it's like, okay, count is equal to 0. Okay, for now we'll just put a cache decorator. Oh, we can't cache a dictionary, right? Here we'll do self.memo is equal to this. Tuple of d.values and self.memo. Letter, comma, 0 for letter in okay. Key is equal to tuple of for letter in this. We're abusing the fact that this is constant time. Memo returns self.memo of key. There we go. All right. For letter in Actually, D always has the alphabet letters, right? The letter in D. here we'll say letter comma in d dot items. If frequency original d is equal to d dot copy. Key comma frequency for frequency in d of copy dot items if rec otherwise, he will say d of letter minus or equal to 2 if it's less than 2, yeah? Count plus or equal to self.dp with d and d of letter plus or equal to 2, kind of like a backtrack thing, right? And here we'll say self.memo of key is equal to count, return count. First of all, does something like this work? No, it does not. Oh. Although I always return. The sum of d dot values, let's go to 1, return 1. And then so this greater equal to k, no? Is that it? Not quite. Ah. No. Oh wait, I don't think I understand the problem. Anna plus ELBLE itself as an adjoint is not a full palindrome. I thought it was the number of palindromes you can create using the letter of this, and if it's greater or equal to k. So I solved a different problem. So what it wants you to do no. K is essentially the number of partitions you want. If you can use all the characters in S to construct K Palindrome Strings. So these are possible solutions. Okay. What I thought it meant is like essentially grab these letters, count the total number of ways you could form a palindrome with these letters if possible, and so on and then if it's greater or equal to K. No, you want to split S into K sections that are each palindromes. Okay. Essentially, in order to split off a section to be palindrome, can only do so if frequency or at most one letter has odd frequency. Alright, essentially. Okay, so if anything, this is not even DP. This might be sliding window. No, DP with sliding window. Right? Because you don't know if you essentially want to cut off at a certain point. You don't want to assume you're lucky, right? You only want to cut off at points you can cut off. All right, DP, incorrect. Here we'll do def DP self. We'll take in a 9, a K, right? I is greater or equal to length of self.s. We'll return to, first of all, I want to always assert greater equals 0, K is equal to 0. Or no, this is not how it's going to work. We're going to need some form of dictionary here. Yeah. My idea, essentially, it's like, for every single, position in the string, we're going to say, you can cut here if you want to. I only want to allow you to cut here if there is actually a palindrome before you, right? Every time you cut, I want to reset case 1, cut string index I. Can only do so if D reset D There we go. Denote values like this. There we go. It will return self.dp with what? Like an empty dictionary, index 0, and initial index K, right? Case 2, cut string index equal self.dp. Here we'll say, here we'll call this a default dict event. Fine. Yeah, here we'll do that. Whatever. SOI. We still need K partitions. Here, just in case, we do the deal letter -1. Here will be like, case 1 or case 2. If I, K. is terrible. What's the... Yeah, I can't do it as I and K. It's gonna be n squared here. I can have up to 10 to the 5 partitions, really now. Wait, if anything, why didn't my original idea work? Oh, it's when K is super small. This is an interesting problem. Okay. The more I think about this, the harder I realize this problem actually is. Okay. K Palindrome Strings are false otherwise. Okay. My intuition, it's the hard part is that it's exactly K, not at least K, right? That's the problem. If anything, I can go back to my DP incorrect and start fixing it. And I want to get to a point where I can get exactly K. Like here, if I did something like this, what about self.dp of D, turn K in self.memo of values? Not quite, eh? No, not quite. Oh no, because the point is I'm trying to do the ends. Yeah, this is just not gonna work. Yeah, it's thinking no, but the point is, yeah, it's a different problem I'm trying to solve. Wait, what the hell? What? Well, okay. If we're TLing on that, then good luck. Oh, but we're not caching. Oh no, we are. are. Okay. Yeah, there's gotta be a better way of doing this. Right, if anything, I need to have like K buckets, right? I need to make K buckets of strings. Essentially, I can allocate my resources into each bucket. Such that I can only, yeah. This is, okay. I think that's a better idea. Create a collection of K buckets. For each bucket, you will have a frequency dict of to letter frequency, and you can only tolerate at most one letter having an odd frequency to always keep it a palindrome. Buckets be equal to this range K. So it'll be self.buckets. Right, so this will be, the only thing is if I do O of K work inside of each of O of N DP calls, it's going to be too slow, right? Ah, no. The point is to always use up I in the bucket till a decision is made. Or self dot if anything, we want to pass K denoting K available buckets to have an odd level frequency letter inside of. In each DP call, we will give ourselves choice of wait, I want to check putting a frequency 2 character into a bucket, which we must use up a new bucket for. Also, am I stupid? Is this just gonna be like K doesn't have to be up to 10 to the 5. All he cares about if it's 26 or not, right? Like if K is greater than 26, we just return true, right? Is this just to throw us off? Because what if I do this? Yeah. Let's do this. D is equal to this exactly. This exactly. We'll letter in S. Sum of Wait, is that literally it? No, wrong answer here. Why? Length of gray root quarter K and does this work? Bruh. Okay, completion streak 179 days. Consistency is key. See ya tomorrow. Okay. Oh, that's kind of funny because as I was writing how I was gonna do this in DP, I was like, okay. Wait a minute. I can just infinitely put two of the same letter in the same bucket over and over and over, even if the buckets are all odd. So really the only time I get screwed is when all K buckets have at least one letter with odd level frequency and I want to add an odd level frequency letter. But I can have at most 26 odd frequency letters because there's at most 26 letters in the English alphabet. So K being so huge is really just like throw you off, right? Or it's like, you know, cases where the length of S is obviously way smaller than the length of K. Okay. All that work just to realize that it was completely trivial all along. This is the solution, by the way, ladies and gentlemen. And how is it so slow? What? Okay, there's got to be a better way to do this. Okay. If anything, 0 times 26 ord of A is equal to ord of A. If length of S less than K, turn false, right? This is shorter and cooler. Is this faster? No, it's not. How are people doing this so giga-blazingly fast? How are people doing this so blazingly fast? I see, it's like... This would be okay. Does this make it more efficient? Barely. Okay. I mean, okay, if anything, we can just keep our Pythonic little solution just because it's like, okay, if we can't be fast, we might as well be slick, you know? That's what they say. That's what they say. Of course, that's what they say. Okay, no one says that, but, you know, we can pretend they do. We can pretend they do. I like the name frequencies. Right, if anything, we can make this a default dict event d of letter plus equal to 1. And yes, D is defined. There we go. And yeah, and so here we'll do fric and D dot values. Lambda D dot values. Okay, a little bit faster and so on, but yeah. Okay, you know what? Yeah, we must well keep it slick. You know, 4-line solution. There we go. Bada bing, bada boom. Okay, so as always, in all my videos, I do a quick recap if I was able to solve the problem. So for this one, turns out I was overcomplicating it like crazy. I can kind of go over the idea. Like I know the solution is very, very short. I was really going down the, I wouldn't say necessarily wrong direction, but I was trying to do this in like a dynamic programming type of way, and I was doing it at some point. I was like, wait a minute, DP is useless for what I want to do, right? So here, let me explain. So the point is that essentially I misread the problem the very first time that I solved this. The actual problem, what it's asking for is take a string S, can you split it into k separate sections? Where each of those k separate sections, you can add whatever letters you want from S into those k sections, but you must add each letter in S to one of the k buckets you have, and at the end have it such that all k buckets are palindromes, right? So for example, here they took the letter, so here they took every single letter except B and put it into bucket number 1, and then put B and put it into bucket number 2, right? So in each of these, there's 2 buckets, right? It's just weird the way they do the pluses and so on. What you realize is that something like Anna plus ELBLE altogether is not a palindrome. The point is that Anna is a palindrome and ELBLE is a palindrome. So they have one bucket where there's a palindrome and another bucket where there's a palindrome, right? So essentially, it's like you're able to essentially take every character of string S, put it in one of the k buckets that are available to you, and at the end of the day, you want all k buckets to be palindromes, right? So that's why I had a kind of a DP mindset where it's like, okay, I'm gonna make a bunch of buckets, and then for every single letter, I'm gonna make a decision of like, you know, which bucket do I put it into? The point is I don't know, blah 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 blah, right? Now a very easy thing to realize is that like, okay, if I just take, you know, first of all, there's only lowercase English letters, so there's at most like 26 unique characters, right? What I can do is grab the frequency of each letter inside of the string S, right? And first of all, okay, if the length of a string S is less than k, right, that means I need k buckets where they're all palindromes, and I have less than the number of buckets, number of letters. Well, I guess this shouldn't be necessarily true, right? Because, oh no, the point is I can't, like, you know, basically the k buckets must be non-empty, right? You can't have empty strings and so on. The point is that you must split the string into k sections. So if you have more buckets that you need to put palindromes into that are non-empty, then you have letters available to you in S, you definitely can't partition it into k buckets, right? So the very first thing that we check is like, okay, make sure that the length of S is greater or equal to k, otherwise it's like, you know, we're guaranteed false, right? So you could add it as a statement at the very top and so on. Maybe that's a bit more efficient, but here I just want it to be nice and chic with my Pythonic little solution, right? If anything, I wonder if can I get away with something like this in Python? Probably not, right? I can. I don't know if I can, but yeah, that way it's like essentially I can even make it even more chic. There we go. 3-line solution. Even though it's slow and so on, I don't get why it's so slow, but there we go, right? But the point is that if essentially I keep track of the frequencies, like, you know, if anything, like here, just to make it clear, we'll do letter colon frequency of 0 for letter in the alphabet, right? So A, B, C, D, E, F, G, H, let me make sure that I'm doing A, B, C, D, E, F, G, H, said, okay. And so for every single letter in the alphabet, and then it's like, okay, for every single letter in S, we're going to augment that letter plus or equal to 1, right? I guess it's just like if you do a default dict, it's a little bit more general, right? But this might be a little bit better for this specific use case. You know what? Nope, not even that. Seems like default dict is better. And, you know, in case you weren't limited to lowercase English letters, that way this algorithm would still work for that, right? So we might as well use this algorithm. It's a little bit more flexible. But okay, in terms of how I was able to solve the problem, obviously, like, you know, we must check the length of S is greater or equal to K, so that should make sense. And then the next thing we need to do is like, okay, let's grab the frequencies of each letter in S, right? Now, if the frequency of a letter is, let's say, even, right? Then you could put those two letters at the end of a word that is a palindrome and keep it a palindrome, right? So if essentially, if you have an even letter, if you have a letter with an even frequency, you can just put half of it here, half of it here, inside of the word of any of the buckets, and just keep the word as a palindrome, right? So if you have an even frequency for a letter, great. You can exhaust all of those letters, and essentially you can keep everything as palindromes inside of your K buckets, right? The point is that essentially, if your length of the string S is greater or equal to K, good, then you're going to put, like, you know, essentially, you're going to have some letters that are going to have an odd amount of frequency, right? In those cases, essentially, it's like you can keep doing -2, -2, -2, -2, right? Because if you have more than 2 of a specific letter, you can grab 2 of that letter and take a word inside of your K buckets and put it at the beginning and at the end, right? So if, like, you know, if I have K buckets here, right? So at the beginning, it's like I have K buckets. I have my buckets. Here is this and this, right? And then I have my string S, right? Here, essentially, I'm going to have a dictionary of letter to frequency counts, right? So here I have A appears twice. Then I have B appears once. Then I'll have E appears twice. L appears twice. L and N appears twice, right? Then it's like, okay, I only want to split them across 2 buckets, right? So for all of those that have an even frequency, great. You know what? I can just start spamming that, right? So here I have AA, okay, I'll spam AA right here, and I just got rid of my A's, right? B, okay, that has an odd frequency, so let's ignore it. EE, cool. I can put that into another bucket. I can put it into a new bucket. You know what, for the sake of example, we'll put it here and here. Okay, there we go, right? And this is still a palindrome. EAAE is a palindrome. Here, okay, this is even, not a word in the world. We'll just grab it in here, and we'll do L and L over here, right? And here, it's like, okay, we'll grab this guy. It's like, you know, just put an N here and an N here, right? So the point is that, like, you know, if you have an even frequency letter and so on, and you could do it with 4, right? Imagine we had 4 N's. We could put even more N's, like, on the sides like this, right? And the point is that essentially you keep the whole thing a palindrome no matter what. The only problem is when you have an odd frequency letter, right? Now, a palindrome, essentially the middle of a palindrome can be of length 0 or length 1, right? If I have something like EEE, this is a palindrome, but I could have EEE again, right? And here, if I have no character, then this is a palindrome. But if I have some random character like H in the middle, this is still a palindrome. So essentially, if I have an odd frequency letter, okay, great. I can still put it inside of a palindromic string like this, as long as it is the only character that I put in there that, you know, is of odd length. So it's like, essentially, it's like, you know, for every single character that has a frequency that is odd, I essentially get to use up 1 bucket, right? So either I can pick this bucket over here, or for example, here I could pick up this bucket here and be like, okay, B, I will get rid of 1 B here, right? So now it's 0, and since it's even, essentially, it's like, you know, you can put 0 B's on the left hand, 0 B's on the right hand. The point is, like, when a number is even, you're big chilling, right? We showed that why. But when a letter is odd, then essentially you must use up exactly 1 of that letter, and then the rest is even. So it's like when you do -1 of a odd number, it's even. So now it becomes easier again. But the point is that you use up a bucket, right? So now this bucket, it used to be able to tolerate taking you know, an odd character letter like B and so on, but now it can no longer do so, right? So if I had another character like D, for example, that is like, you know, I have 3 Ds, right? I could subtract this by 2, right? To make it a 1 and put like, you know, Ds on the end of this guy. But here I cannot put a D, right? I cannot put a D anywhere that would keep this as a palindrome. Essentially, I only get to put like, you know, a singular letter at the center of a palindromic string that is even to make it an odd palindromic, but still palindromic string. And there you go. So essentially, what I can transform this problem into is like, for each letter in S, grab its frequencies and pay attention to those that have an odd frequency. Because those that have an odd frequency must become the central letter of a palindrome inside of a unique bucket. So the point is, okay, the question I need to ask myself is, how many letters do I have with an odd frequency? Because if I have more letters with an odd frequency than I have buckets available to me, then it's game over. I cannot put them all in a bucket, right? Because of pigeonhole principle, right? I'll have to have at least one bucket that I put 2 of the same, you know, odd frequency letters in, which will break the fact that it's a palindrome. Therefore, I cannot do it, right? And then in terms of like, you know, whether or not we can use all K buckets and so on, then it's like, you know, we are not really scared about that, because it's like, you know, since like the vest is greater or equal to K, like, you know, worst case we can put like, you know, a single character of the odd frequency letters inside of each unique bucket. And then otherwise it's like, if, you know, each letter is of even count, then great, we can just put an even count of that letter inside of everywhere inside of the K, right? So like the point is that like, if anything, if you're like, if there's too many buckets, like, you know, since like the vest is greater or equal to K, it's like, you know, you could take 2 E's, and instead of putting them inside of one bucket, you could be like, okay, we'll have one bucket where E is the center of that bucket and another E at the center of another bucket and so on. So you can always fill it in the way that you need to do and so on. So we don't have to worry about those weird cases where it's like, do I have enough buckets and so on? No, those are already implicitly handled. But the core idea is essentially, it's like, you know, look at the frequency letters of the characters in S, and essentially count the number of letters that have an odd frequency. Because if it's an even frequency, then you have the flexibility of whatever you want, right? If you have an even frequency letter, right? For example, let's say that we have an F here that happens like, you know, twice here. The point is that when you have an even frequency letter, you have 2 options, right? Let's say we had more buckets like this here. One option is take something like this. Hey, sorry about that. Another one of my Nico 150 recordings just popped up and so on, so I had to just cut that out of the video, but let's continue from where I was. So essentially it's like, you know, if I have an even letter, a string like F, the point is that I have the flexibility of doing whatever I want, right? Of which I only have 2 options. One option is essentially added as like, you know, the ends of one of the strings inside of a bucket, right? Whether it's a new bucket or not and so on. And just like, you know, keep something as a palindrome, right? So here's like, I could take 2 and it's like, you know, I could put FF, right? I could put it in a new bucket like this, or I could put it in an existing bucket like this where I have letters, right? Or what I can do is put an F here and an F here and essentially have it be the middle of those things, right? So here's like, you know, I have B is 0, as imagine I didn't do B is here, and I have a B here, right? So if anything, it's like, you know, I have F here, right? Something that I can do is essentially it's like, okay, let's put an F here and an F here and subtract that and make it at 0, and then it's like, you know, put a B here at the center of this guy, right? So the point is I could have made it the middle of this one, middle of this one, middle of this one, and so on. So it's like when you have an even length, even frequency character, the point is that you have the infinite flexibility, right? You can, if you want, you can keep it as like, you know, the ends of a palindromic string, or you can start filling up buckets that you need to fill up and so on. Like, you have a crazy amount of flexibility. You can essentially do what you want. The things where you don't have flexibility are characters inside of S that have an initially odd frequency, right? Because essentially you must use up at least one character from, or exactly one character out of like, you know, something with an odd amount of frequency, and make that the center of one of the palindromes inside of one of the K buckets, right? It could be that like it's, you know, it's like a big thing like this, like 5, right? In which case it's like you could put a B here, and subtract this by 2 and make this a 3, right? And then it's like you could put like a B here, and like make this a 1. But then it's like, you know, that last remaining one, you know, because it used to be initially odd, you have to put at the center of something, right? You could put it at the center of here, you could put it at the center of here, you could put it at the center of like right here and so on, but you must choose a bucket and make it the center, right? And so essentially, since we want to split since we want to use up all the characters in S and essentially distribute them amongst K buckets, right? And essentially have every single string inside of each bucket be a palindrome, what we just want to count then is like, okay, let's grab out of all the characters in S, let's count the ones that have an odd frequency, and essentially ask ourselves like, okay, is the number of odd frequency letters less than or equal to the number of buckets available to us, right? Because if it's more than the number of buckets that we have available to us, then it's GG, right? For example, here, let's pretend that we have, let's make it simple, right? Let's pretend we have 2 buckets, but 3 letters with an odd frequency, right? So here we'll have a C of 5. right? It doesn't matter what we do, right? We could put two C's right here. We could put like two F's right here, right? So this becomes 1 and this becomes 3. We could even put two C's right here on this end and so on. But now it's like, you know, the inevitable happens where it's like, okay, I must put this at the center of somewhere to essentially get rid of this B. So let's put it at the center of here. Here it's like, okay, I gotta put this at the center of somewhere. If I can't put it in here because otherwise I break this being a palindrome, so the only place I can put it is in here. Okay, there we go. And then it's like, you know, I still have 1 C remaining, right? And it's like, if I add it anywhere in here, then it's no longer a palindrome. If I add it anywhere in here, then it's no longer a palindrome. I'm stuck, right? So if the number of like, you know, odd frequency characters inside of S is more than essentially the number of buckets that I essentially have to essentially put characters in, distribute characters into, which is K, right? The number of buckets, then and only then I say, oh, okay, I cannot partition it into K palindromes and so on, and then I return false, right? So here what I do is, you know, fancy code, but essentially it's like, okay, D is essentially a dictionary that maps letters in S to their frequency, and for every single, you know, the frequency of every single letter, I'm going to grab that value modulo 2 to essentially say like, you know, 0 if it's even, 1 if it's odd. So since 1 is odd, then essentially take the sum of that. So it's like, you know, 0, even, 1 is odd. The sum will be the number of odd frequencies that I have inside of my dictionary D of, you know, from the letters of S. So essentially this represents like, you know, the number of letters that have an odd frequency inside of the string S. And so I want to make sure that that's less than or equal to K because I essentially have K buckets, right? And again, remember that I don't have to worry about like, you know, whether I have too many buckets, not enough buckets and so on, because with letters that have an even frequency, I can do whatever I want. So as long as, you know, length of S is greater or equal to K, then we're Bing chilling. There we go. Bada bing, bada boom. And so hopefully that solution makes sense. And for length of S greater or equal to K, we know that if length of S is less than K, then we straight up just cannot do the problem, right? Because we need K buckets that are not empty, but we don't even have K characters to choose from at all inside of S, so we can't fill every single bucket in the first place, even if we do 1 character per bucket. So obviously if length of S is less than K, we definitely can't do the problem, right? It's just that if this condition holds here, it will always be true as long as length of S is greater or equal to K. So hopefully that solution makes sense. And yeah, for some reason it's like, you know, a little bit slow. I can't imagine like, you know, there being a better time complexity algorithm and so on. So I don't know how people did it. So if there's a, you know, a better way of essentially doing this problem, then you know, please let me know down in the comment sections below. But yeah, otherwise that is pretty much it for this video. If you did find this video enjoyable or useful in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I will catch you in the next one, my friends. So until then, ciao, my friend. Bye-bye.